See here, in the last class, we have done problem related to consistency of a system of linear equation. Okay. Now see here. So this is a system of linear equation. See here, find for what values of lambda and mu, the system of linear equation. So this is the system of linear equation, x plus y plus z equal to 6, and x plus twice y plus 5z equal to 10, and twice x plus 3y plus lambda z equal to mu, has a unique solution, has no solution, has infinite solutions. Also find a solution for lambda equal to, solution for lambda equal to 2 and mu equal to 8. Okay, so at first we have to find the transpose this matrix. See here. So, so this coefficient of x, y, and z is 1, 1, 1. So that's why it is 1, 1, 1. Here coefficient of x is 1, y is 2, and z is 5. And here coefficient of x is 2, y is 3, and z is lambda. And x, y, z equal to, these are 6, 10, mu. 6, 10, mu. Clear? So as a whole, this system can be written as Ax equal to B. And you already know that what is augmented matrix, where C is equal to what? A is to this matrix B. That means this is the matrix A and this is the matrix B. Clear? Now, since it is already 1, we can easily make these two equal to 0. Okay, since it is 1, we can make easily these two elements equal to 0. So how this is, see here, row 2 tends to row 2 minus row 1. So 1 minus 1, which is equal to 0. Now this is 2 minus 1, which is equal to 1. Again 5 minus 1, which is equal to 4. Again 10 minus 6, which is also equal to 4. Again row 3 tends to row 3 minus 2 row 1. Row 3 tends to row 3 minus 2 row 1. So 2 minus 2 into 1. That means 2 minus 2, which is equal to 0. Again 3 minus 2 into 1. That means 3 minus 2, which is equal to 1. And lambda minus 2 into 1. Okay, lambda minus 2, that means is to, same way mu minus 2 6 are 12. Mu minus 2 6 are 12. Clear? Now see, again, you can make this element equal to 0 by using this one. You can make this one equal to 0 by using this element 1. Clear? So how you can make this? Row 3 tends to row 3 minus row 2. Row 3 tends to row 3 minus row 2. So row 1 remains same. Row 2, this one, and what is row 3? Row 3 tends to row 3 minus row 2. So 0 minus 0, it will be 0. 1 minus 1, which is equal to 0. And lambda minus 2 minus 4. It will be lambda minus 6. Is to mu minus 12 minus 4. That means mu minus 16. Okay. Now come to the question. So what it is given, we have to find out the value of lambda and mu. We have to find out the value of lambda and mu so that the given system of equation has a unique solution. Clear? So it has a unique solution. So at first, when it has a solution, if rank of this matrix A is equal to the rank of the whole augmented matrix C. Clear? only then it has a solution. And unique solution, when it has an unique solution, if if its rank is equal to the total number of unknowns. So how many unknowns are there? Three unknowns, x, y, and z. These are the only three unknowns, x, y, and z. Clear? So that's why a unique solution when if rank of A equal to rank of C equal to 3. Clear? So when the rank of A is equal to 3, if this third row is not equal to 0, that means this lambda minus 6 cannot be equal to 0. Okay, because if lambda minus 6 equal to 0, then what happened? It becomes 0 row. That okay. So therefore lambda minus 6 cannot be equal to 0. So that means lambda cannot be equal to 6. Okay. See here, then lambda minus 6 not equal to 0 and lambda not equal to 6. Okay. And actually there is no problem. If it is 0 also, if mu minus 16 is 0 also, then what happened? There is no problem because already the rank of the augmented matrix is equal to 3. So you can put lambda any value. Okay, value of value of mu can be any value. It can be 16 also, no problem. There is some mistake, that's why. Now come to the second one, no solution. Clear? No solution. So when there is no solution, if the rank of A not equal to the rank of the augmented matrix. Okay. If rank of this matrix A not equal to the rank of this augmented matrix. Clear? So that means what happened? Rank of A must be equal to 2 and rank of the augmented matrix must be equal to what? 3. So when the rank is equal to 2, when its rank is equal to 2, if this row becomes equal to what? 0. So when it is equal to 0, if lambda minus 6 is equal to 0, that means lambda equal to what? 6. Then if lambda equal to 6, then this row becomes equal to 0 and rank of this matrix then become equal to what? 2. Because then what happened? Only 2 non-zero rows are there. Clear? And what about the augmented matrix? So if mu not equal to 16, if mu not equal to 16, then what happened? The rank of the augmented matrix is equal to 3. Okay, if mu not equal to 16, then rank of the augmented matrix is equal to 3. So in that case, what happened? There will be no solution. Clear? Now infinite number of solution. So you already know that when there is an infinite number of solution, if rank of the matrix is equal to the rank of the augmented matrix is less than the number of unknowns. Okay, is less than the number of unknowns. So here what happened? How many unknowns are there? 3 unknowns are there. 3 unknowns are there, which are x, y, and z. Now, if both the rank of A and rank of augmented matrix is equal to 2, then what happened? It is less than to 3. Okay, so then only what happened? It has infinite number of solution. So when rank will be equal to 2, if lambda minus 6 is also equal to 0, as well as mu minus 16 is also equal to 0. Okay, as well as mu minus 16 is also equal to 0. That means what happened? So that means what happened? Lambda is equal to 6 and mu is equal to 16. Okay, lambda is equal to 6 and mu is equal to 16. Clear? So in this way, we can find out the value of lambda and mu. Okay, and the fourth one is what? third one, also find a solution for lambda equal to 2 and mu equal to 8. So if lambda equal to 2, if lambda is equal to 2, then what happened? It will become 2 minus 6. So it will be minus 4. And if mu equal to 8, then it will be what? 8 minus 16. That means minus 8. Clear? This one. So putting lambda equal to 2 and mu equal to 8, we got this one, 0, 0, minus 4 and minus 8. So after that, we can multiply this one. All of you know this one, 1, 1, 1. This is 0, 1, 4, 0, 1, 4. Again, after that, 0, 0, minus 4. 0, 0, minus 4. This is x, y, z, which is equal to 6, 4, minus 8. 6, 4, minus 8. So after multiplying this matrix, see 1 into x. So x plus 1 into y plus y plus 1 into z. Okay. So plus 1 into z, which is equal to z equal to 6. Again, y, 1 into y. 1 into y, which is equal to y plus 4 into z. 4z equal to 4. Again, minus 4 into z equal to minus 8. So from here, what you got? Value of z is equal, if divide, both side divide by minus 4, you got z is equal to 2. You got z is equal to 2. So putting z equal to 2 in equation number 3, if you put z equal to 2 here, then what you got? Y plus 8 equal to 4, then y equal to 4 minus 8, which is equal to minus 4. After that, simply you have to put the value of y and z in equation number 1, and you will get the value of x is equal to 8. Clear? Now tell me, is there any doubt?
So in unique solution part, there is a doubt.
In unique solution part.
So can you bring the slide again?
Yeah,
So
yeah.
where's the slide? So you it was written like RA equal to RC equal to 3. So that part, so 3.
Yeah, it's one. Come here. See, so when there is a unique solution, okay, listen it carefully. When there is a unique solution, so if the rank of the matrix, is equal to the rank of the augmented matrix is equal to the total number of unknowns. Clear? So in this case, what happened? What is the total number of unknowns? There is 3 unknowns, x, y, and z. So what happened? If the rank of A is equal to the rank of this augmented matrix is equal to 3, then what happened? It has a unique solution. It has an unique solution. Clear? Now, my point is, if lambda minus 6 not equal to 0, then what happened? You got lambda not equal to 6. That means what? This row is already non-zero. When lambda minus 6 is not equal to 0, then this third row is already non-zero. Is it or not?
Yes.
Okay. When lambda minus 6 not equal to 0, then the third row is already non-zero. So there is no problem whether mu minus 16 is 0 or not. Can you get my point? Okay.
So good.
Once we got this element is non-zero, that means what happened? Rank of A is equal to 3 and rank of all this augmented matrix is equal to 3. There is no problem whether mu minus 16 is 0 or not. Clear? Actually, there it can be any values of mu. Okay, but
Mhm.
lambda cannot be equal to 6, because if lambda equal to 6, then this row becomes equal to 0 and the rank of the matrix A becomes equal to 2. Then there will be no solution. Clear? Now, if
Mm.
lambda not equal to 6, and in that case, mu can be any value, no problem. Now it is clear?
Yes, sir.
Now see here, I will start different type of. Now it is homogeneous equation. Okay, so previous one we discussed about those are non-homogeneous equation. So non-homogeneous equation means what? A system of equation in the form ax equal to b. Okay, that means if the right hand side is not equal to 0, then that system of equation is called non-homogeneous equation. And if the right hand side is equal to 0, then that system of equation is called homogeneous equation. So the previous problems we discussed, those all are non-homogeneous equation. Now we are going to discuss how we can find out the solution of a homogeneous system of equation. Clear? That means homogeneous equation means, suppose we take a equation thrice x plus 4y minus 5z equal to 0 against x plus y minus 5z equal to 0. That means the right hand side is equal to what? 0. Okay, so that type of equation is called homogeneous. Here, now see here. So for a system of homogeneous linear equation, Ax equal to 0, x equal to 0 is always a solution. Okay, this solution is which each unknown has the value 0 is called the null solution or trivial solution. Okay, thus a homogeneous system is always consistent. Now come to the point what it is given. X equal to 0 is a solution. Okay, so you can note down yourself. Suppose you take a equation 5x minus 3y plus z equal to 0. 5x minus 3y plus z equal to 0. Then what happened? If you put x equal to 0, y equal to 0, z equal to 0 in the left hand side, then the left hand side becomes equal to 0. Okay, so right hand side is already equal to 0. So in that case, what happened? This x equal to 0, y equal to 0, z equal to 0 is the solution of this equation. Okay, is the solution of this equation. Okay, and this solution is called null solution or trivial solution. Okay, that means if you get x equal to 0, y equal to 0 and z equal to 0, then what happened? This solution is called null solution. All of you know null means what? Empty. Since it is 0, that's why it is called as null. Okay, it is called null solution or trivial solution. Clear? Now listen it carefully. For any homogeneous equation, this x equal to 0, y equal to 0, z equal to 0 is always a solution of this equation. Clear? You can check yourself. Okay, and this solution is called trivial solution or null solution. So it is given, does a homogeneous system is always consistent. That's why, since there always exists a trivial solution, so that's why a homogeneous system of equation is always consistent. Now, a system of homogeneous linear equations has either the trivial solution or an infinite number of solution. Now come to the point. A homogeneous system cannot have a unique solution. Okay. A homogeneous system of equation cannot have a unique non-zero solution. Okay. One thing you already know, a homogeneous system of equation always has a trivial solution, that means zero solution. Again, it may have a infinite number of solutions. Clear? Again, it may have an infinite number of solutions. Clear? So first one, if rank of A, that means rank of the matrix A, is equal to the number of unknowns, then the system has only the trivial solution. So this Ax equal to 0. If rank of the matrix is equal to the number of unknowns, then what happened? The system has only trivial solution. Trivial solution means what? X equal to 0, y equal to 0, z equal to 0 are the only solutions. If three variables is there, if more than three variables, then all that three variables must be equal to what? 0. Now, if rank of A less than the number of unknowns, then the system has an infinite number of non-trivial solutions. Okay, infinite number of non-trivial solutions. Non-trivial solutions means what? Those unknowns not equal to 0. If the unknowns are equal to 0, then it is called trivial solution. And non-trivial solution means what? Unknowns not equal to 0. Now see here, a system of homogeneous linear equations Ax equal to 0. A system of homogeneous linear equations Ax equal to 0 always has a solution. Okay, either it may be a trivial solution or it may have an infinite number of solutions. So to find out this, at first we have to find out the rank of the matrix. Okay, at first we have to find out the rank of the matrix. So now there are two cases. If rank of A is equal to n means number of unknowns, then it has unique or trivial solution. That means each unknown are equal to 0. Okay, each unknown are equal to 0. Now, if rank of A less than to n, that means number of unknowns, then it has infinite number of non-trivial solutions. Okay, so these are the only things in case of homogeneous linear equation. So let's try one example. Now see here what is given. Determine B such that the system of homogeneous equation, so it is a system of homogeneous equation. Why it is homogeneous? Because in all these cases right hand side are equal to 0, has trivial solution. Okay, it has trivial solution. So we have to find out the value of B so that the system has trivial solution. Clear? Now come here, see. So one thing, trivial solution means what? X equal to 0, y equal to 0, z equal to 0. In all these cases, you can see here, if you put x equal to 0, y equal to 0 left and z equal to 0, then obviously the left hand side is equal to 0. So same thing happened here also and here also. So there is no problem. What is the value of B? Okay, B can be anything, is it or not? Means already x, y, z are 0. So obviously this obviously equal to 0. So there is no problem. What is the value of B? Let's see. Yeah. For trivial solution, we know that x equal to 0, y equal to 0, z equal to 0. So B can have any value. Okay. So B can have any value for trivial. X equal equal to 0, y equal to 0, and z equal to 0. So D can have any value. Now for non-trivial solution, that means if x, y, and z not all are equal to 0, let's see here. See here. So given equations are written in the matrix form as 2, 1, 2, 1, 1, 3. This is 2, 1, 2, 2, 1, 2, 1, 1, 3. Again, this is 4, 3b. 4, 3b into xyz equal to 0. Clear? So in this case, here it is given augmented matrix C. So obviously these are equal to 0. You can directly write only A also, no problem. You can directly write only this matrix A also, there is no problem, because the B is already equal to 0. So no need to take this one. Okay. Now see here, in the first step, what happened? We interchange row 2 with row 1 so that these elements becomes equal to 1. We interchange row 2 with row 1 so that this element becomes equal to 1. So what do we got? This 1, 1, 3, 1, 1, 3, and this 2, 1, 2, 2, 1, 2. Third row is already 4, 3b, 4, 3b. Now using this one, we can easily make this one and this one equal to 0. So how we can make this equal to 0? Row 2 tends to row 2 minus 2 row 1. Okay, that means 2 minus 2, which is equal to 0. 1 minus 2 into 1, that means 1 minus 2, which is equal to minus 1. Again, 2 minus 2 3s are 6. That means 2 minus 6, which is equal to minus 4. Okay. Again, for the last one, row 3 tends to row 3 minus 4 row 1, because 4 minus 4 into 1, which is equal to 0. 3 minus 4 into 1, 3 minus 4, which is equal to minus 1. Again, b minus 4 3s are 12. That means b minus 12. Okay. So you got this is minus 1. Again, you can make this equal to 0 by using this. How you can make this equal to 0? Row 3 tends to row 3 minus row 2. So minus 1 minus minus 1. So minus minus it will become plus. Again, b minus 12 minus minus 4. That means b minus 12 plus 4. So it will be b minus 8. Okay. Now this is the matrix A. So when it has an infinite number of solutions, if rank of the matrix is equal to, if rank of the matrix is equal to the rank of the matrix is less than to the number of unknowns. Okay, so here how many unknowns are there? 3 unknowns, x, y, and z. Now if b is equal to a, then what happens? Rank is equal to what? Less than to 3. Yeah. Now rank of A is 2. So what happened? Value of B must be equal to what? A. Since it has an infinite number of solutions, so rank of A what happened? Must be less than the number of variables. So when it is less than the number of variables, if B minus 8 is equal to 0, b minus 8 is equal to 0. So b minus 8 is equal to 0 means what? If b is equal to what? Okay. If b is equal to 8. Clear? Then what happened? It has an infinite number of solutions. That means non-trivial solution. Always remember, non-trivial solution means non-zero solutions. That means all of those unknowns not equal to 0. One unknowns may be equal to 0, no problem. But what happened? All the unknowns cannot be equal to 0. That is called non-trivial solution. Trivial solution means what? All the unknowns are equal to what? 0. So come to the next question. What it is given? So this is the last question of this topic. Okay. So find the values of k such that the system of equations has non-trivial solution. Find the values of k such that the system of equations have non-trivial solution. Okay. So this set of equations is written in the form of matrices. We can write this in this way: 1k and 3, 1k 3. Again, this is 4 3k, 4 3k. Again, this is 2 1 2, 2 1 2 into this column matrix xyz. Right hand side is already equal to 0. So your augmented matrix is this one. Okay. So here, this is 1k3. Here there is one thing, we interchange first row and third row. We interchange first row and third row. Why we interchange first row and third row? Because in the first row there is k. Okay. Again, we are going to find out the value of k. So it is difficult when it is in the first row. So that's why we interchange first row with the, that's why we interchange first row with the third row, so that k is in the third row. Okay. So this is 2 1 2, 4 second row remains same, 4 3k, and the third row is 1k3, 1k3. Okay. 1k3. Now see here, row 2 tends to row 2 minus 2 row 1, 4 minus 2 into 2, it will becomes equal to 0. And row 3 tends to row 3 minus 1 by 2 row 1. 1 by 2 into 2 means what? 1. So 1 minus 1 becomes equal to 0. Okay. See here, row 2 minus 2 row 1. So 4 minus 4, it will becomes equal to 0. 3 minus 2 into 1. So 3 minus 2, which is equal to what? 3 minus 2, which is equal to 1. Okay, 3 minus 2, which is equal to 1. Again, k minus 2 to the 4. So it will be k minus 4. Again, row 3 tends to row 3 minus half row 1. Okay, half row 1. So obviously 1 minus 2 into 1 by 2. So it will be 0. K minus 1 by 2 into 1. That means k minus half. 3 minus 1 by 2 into 2. So 3 minus 1, which is equal to 2. Okay, clear? Now see here, now our aim is how we can make this. It is very important. See here, because at first we have to make it into the triangular form or echelon form. So to make this matrix to the triangular form or echelon form, this element must be equal to 0. Okay, so this k minus half must be equal to 0. Now it is very important how we can make this element equal to 0. We did nothing, we simply multiply 1 with this one and deduct it. See here, we simply multiply 1 with this one and deduct it. See, row 3 tends to row 3 minus k minus half into row 2, so that these elements directly equal to 0. Okay. So this is already 0, 0 minus 0. Again, it will be 0. Now row 3, that means 2 minus k minus half into k minus 4. This one. Clear, is to 0. Okay. Now it is in the echelon form or triangular form. Now see here, we have to check whether it has non-trivial solution. Non-trivial solution means what? Rank of the matrix must be less than the number of unknowns. So how many unknowns are there? 3 unknowns are there. X, Y, and Z are the only unknowns. So this must be equal to 0. This one must be equal to 0. So this one must be equal to 0. So after solving this one, we got value of k is equal to 9 by 2 or k is equal to 0. Simply see here, this must be equal to 0, then only rank of the matrix A is equal to 2, and then it has non-trivial solution. Okay, then it has non-trivial solution. So that means these elements must be equal to what? 0. So therefore this one, 2 minus k minus half, k minus 4 equal to 0. So you can see yourself, after solving this, we got k equal to 9 by 2 or k is equal to 0. Okay. So that's all. So in this way, we can find out the solutions of a homogeneous linear equation. Okay, so this is all about what is non-homogeneous system of equation and homogeneous system of equation. Non-homogeneous means if it is in the form ax equal to b. Homogeneous means ax equal to 0. That means right hand side is equal to 0. And what we have to do here, we have to check the consistency. And you already got it that a homogeneous system of equation is always consistent. Okay, it may become in terms of MCQ. So be prepared for that. Homogeneous system of equation is always consistent. Either it has a trivial solution or it has an infinite number of solutions. And non-homogeneous solution, there are 3 cases. You know all of these 3. Okay. Okay, then that's all for today. And from the next time onwards, all of you try to come the class after within 15 minutes. Okay, within 15 minutes. Clear? Now one boys come here, Kosik entered the waiting room. So now the class is already over. Okay, and only 29 students present in the class. So give the attendance of those 29 students only. Okay. Okay, then that's all for today. Next class it is very important. I will start the eigenvalues and eigenvector. Okay, then that's all for today.